54. A 0.72 mole sample of PCl5 is put into a 1.00 liter vessel and heated. At equilibrium, the vessel contains 0.40 moles of PCl3 gas and 0.4 moles of Cl2 gas. Calculate the value of the equilibrium constant for the decomposition of PCl5 to PCl3 and Cl2 at this temperature. All right, so the question is asking, we need to find an actual value, an actual number for the equilibrium constant, right? And remember, equilibrium constants are those capital K values. Now, let's just see, right? How are we going to get the K value? Well, we usually see that the K formula comes from a balanced equation, but they didn't give me an equation here. So the first thing I got to do is I got to make one. Now, they said that PCl5 was being decomposed, right? And it's being decomposed into the two products, right? PCl3 and Cl2. Now, they didn't specifically say what state PCl5 is, but I'm going to treat it as if it was a gas, all right? So we start off with PCl5, and that's a gas. And this decomposes, right? So it turns into, and we're talking about equilibrium, so I do need to see those double arrows, into the two products, PCl3. These, specifically, they said that this was a gas. And the Cl2, this was also a gas. Now just make sure, if I just move this over a little bit, just make sure, right? Is this equation balanced? You could pause the video and check to see if it's balanced, but looks like it's pretty balanced to me. Now, the next thing we basically have to figure out is whether we're doing a Kc formula or a Kp formula, right? So that comes from using the units that they gave you. They're talking about moles, right? And they give you a volume. This is concentration, right? We can get moles and, combine moles and liters into a formula to get a molarity. And that's Kc, right? They didn't give me pressure values, so we're not going to use Kp, right? So we're going to use Kc here. Now, what's the Kc formula? Well, it's this one over here, right? I'm just going to maybe put this a little bit at the bottom here. And remember, for using the Kc formula, we need the brackets, right? So that's concentration of the products divided by concentration of reactants, specifically molarity. And only aqueous and gases are allowed in the formula. But now here's the thing, guys. This formula, you're only allowed to put equilibrium values into the Kc expression. Not initial values, not, change in values, only at equilibrium. So with this one, we gotta just read the question a little bit more carefully. It said that we had 0.72 moles sample was put into a 1 liter vessel and heated, right? So this was the start of the reaction. They literally had a vessel, right? Here's my lovely drawing. And they only put in the PCl5, right? How much? They put 0.72 moles. Then they're saying at equilibrium, now we have the same vessel, but now we have PCl3 and Cl2. So is this part, was the beginning describing equilibrium? No, it was not. It's describing what happened initially. Now, whenever you get that sense, actually, let me just get rid of this. Whenever you get that sense that they give you information that is not at equilibrium, and then they give you information about equilibrium, you have to do something called an ice table. Now, some schools might call it a rice table, but I know it as an ice table. It doesn't really matter which word you use. You're going to get the same answer at the end. So what you're going to do is you're going to just say the letters I, C, E. Ice, right? And if you were using rice, the R represents the reaction. So there's 4 tiers for rice, and then there's 3 tiers if you just want to do the ice table and then just have the balanced equation at the top. Doesn't matter. Now, I stands for initial. Now remember, we're doing Kc values, So I can only put in concentrations. They told me that I had moles, right? But is a mole a molarity? No, right? So the first thing is I got to find out what the initial molarity was for PCl5. Well, remember that formula, right? Molarity equals moles divided by liters. If I had 0.72 moles and I had a 1 liter vessel, I would do 0.72 divided by 1 liter. And that would be my molarity. So in this case, it would be the same number, but just double check. If this was like 2 liters, you would have a completely different number. So always check, guys, okay? So I did start off with 0.72, and now you can put molarity in here, but usually we know that we're using molarity here, so you don't have to put the numbers, but just know that this is molarity, okay, guys? Now, let's go across the chart. We still have 2 more pieces to the puzzle for our initial concentrations, right? We need PCl3 and we need Cl2. Well, did they say that we started off with PCl3 or Cl2? No, the only thing that they said was at equilibrium. And the E stands for equilibrium. So these values, the 0.4 and the 0.4, are not initial values, they're at equilibrium. So did I start with any PCl3 or Cl2? No, I didn't. So I'm going to put a 0 here. 0 for this and 0 for this. Now, let's fill in what we know. They did say that at equilibrium, I now have 0.4 moles of PCl3 and 0.4 moles of Cl2. That's the numbers that go down here on the E line, E for equilibrium. So they said 0.4 moles of PCl3. Remember, this should be in molarity, but by using the molarity formula, mole divided by liter, it's a 1 liter vessel, so the number is going to be the same. But I just want to say that because, maybe on a test and quiz, it's not going to be as easy as 1 liter. So I have 0.4 molarity for the PCl3 and 0.40 molarity for the Cl2. Okay, now remember, if we're using this formula, I have to have values at all equilibrium. I got these 2 values, but what's the issue here? Oh, I don't have the equilibrium value for PCl5. I gotta find this. How am I gonna find this? Well, this comes from the C. C stands for change. This is the change from initial to equilibrium. So you say to yourself, how did I get from a 0 to a 0.4? Well, I just added 0.4, right? And 0 plus this gets me this. How did I go from 0 to 0.4? I did the same thing. I plus 0.4, right? Now, here's the thing with equilibrium, guys. If you add by like a ratio value, you're going to subtract on the other side. Since the products were being added, you would have to subtract on the reactant side. But now, what's the number here? Well, this goes by the coefficients, right? There's a 1 here, a 1 here, and a 1 here because I don't see any numbers. Remember, if you don't see a number, that just means that there's one of them. And for each one, since there's 1 and it's the same change, 1, it's the same change, what do you think this change would be since this number is a 1? It would be the same number. So I'm going to minus by 0.40. And now, this is going to mess this nice color coding up, but maybe if oh my goodness. Maybe if I just write the number out, right? Or actually, I'll highlight this, and then we'll do it again. So now if I do 0.72 minus 0.4, I get 0.32. And now I have all my equilibrium values. These are used in the Kc formula, or we'll say Kc equation. Now we go back to what we've been doing this whole time, guys, right? We got to write out our specific equation, plug the numbers in, and solve for K. So let's get it. Kc equals, let's write out that formula. Products divided by reactants. Take note of the states, guys, but they're all gases here. So we're going to use all three of them. So I'm going to say concentration of PCl3. That was our first product. And I'm going to raise that to the first. You don't have to write that there, right? And then remember, it's multiplied by the next product, Cl2. Close that up. That's to the first, so I don't have to put a number. And then the same thing for the denominator. This would be PCl5. Close that bracket. Raise to the first, but anything raised to the first is the same. So now let's just plug in our numbers. Kc equals, looks like we got 0.4 times 0.4. So technically that would be 0.4 squared, right? And then I'm dividing it by the 0.32 because I only take the numbers at equilibrium. They gave me 0.72, but you see that the 0.72 doesn't go in here. No initial values go into this equation. All right, so now, let's see. Let's just extend this a little bit. And then I think we could do this all in one shot, right? We just multiply the top, divide by the bottom. So 0.4 times 0.4 divided by 0.32, I get 0.5. Sig figs, looks like they gave me 2 sig figs throughout the whole idea here. So I'm just going to keep it as 2 sig figs, so it'd be 0.50. And there is your final answer. That's it, guys. What did you think? This is the first time we introduced the ICE table, so it will get, a little bit of time to understand it, but just know for now that, never initials go into your Kc formula, only the equilibrium. And we kind of use the ICE table to just help us. It's like a helping tool to organize our thoughts to get these numbers. All right? So hopefully this helped. Thank you so much for viewing the video. Subscribe to the channel if you want to help us out, and I will see you in future lessons. Bye-bye.